Hello friends, welcome to our channel Knowledge Amplifier. So in my previous video, I have discussed on Kafka cluster with multiple brokers. What is the problem of having a single broker? First I have discussed, that is, if in our Kafka cluster there is only one single server, and if the server goes down, then neither the producer can publish messages in that particular server, nor the consumer can consume the messages from the topic, right? So to overcome that particular issue, we launched multiple servers. Like in my previous video, I have shown 3 servers, how to launch them in our local system, right? We have created 3 different server.properties file, and we have created 3 different log directories for our 3 different servers, and we have launched the servers, right? So like here, I can show you broker 1, broker 2, broker 3. And when we have created the topic in this kind of Kafka cluster where multiple servers are present, we have seen that if the topic is having 5 partitions, then the partitions are distributed among different servers. It is not like all the partitions are present inside single server, right? And that advantage we have seen, that is, suppose partition distribution is like this, that is partition 0 and partition 2 are in first server, partition 1 is in second server, and partition 3 and partition 4 are in third server. Then due to some reason, if the first server goes down, then only the partition 0 and partition 2, these 2 partitions data we cannot access. But partition 1 and partition 3 and 4, in these partitions whatever data is stored, those will be accessible still, because broker 2 and broker 3 was perfectly running, right? Consumers and producers had no problem to publish the message in the topic and consume the messages in the consumer side, right? Because that time in these kind of partitions, they could publish the message and consume from it. Only problem we have faced, that suppose broker 1 goes down, then partition 0 and partition 2, whatever message is stored in the server logs for this particular broker in these partitions, those we were not able to access, okay? And now in this video, let's see how we can overcome that particular issue, okay? And the concept is very simple. If you have some background knowledge in big data ecosystem, then in Hadoop, among multiple data nodes, suppose in our one particular data node, our required data is stored, and if that data node goes down, to overcome the issue, what we generally do while having a write operation, we take multiple replicas, and different replicas we store in different data nodes, so that if one data node goes down, another data node which is having the same data can serve the requirement, okay? That same approach we are going to follow in Kafka also. So suppose we are having these 3 brokers. What we can do in the back end, suppose we are having our broker 1 where partition 0 and partition 2 are stored. To make the whole system more reliable, what we will do, we will have a copy of our partition in another server, okay? So here our partition 0, the data will be stored, okay? Whatever messages will be coming in partition 0, that will be replicating in another server, okay? That may be this broker 2 or broker 3, okay? That our Kafka will decide, okay? Similarly, for all the partitions, in some other servers will be storing the replica. Like for example, partition 2 data will be replicating in our third server. Partition 4 data will be replicating our this server. Okay, partition 3 data will be replicating in some another server. Like that, if we are storing the replicated data in another server, and suppose one particular server goes down, then that time what will happen, in the another server same partitions data is available, right? So from that particular replicated data, we can basically read and fulfill the requirement of our consumer, okay? And even publishers can publish the messages in that particular replicated data, right? So that's the advantages of having replication, okay? So in simple words, I can say like this way: replication is the process of having multiple copies of the data for the sole purpose of availability in case of broker goes down and is unavailable to serve the request, okay? So if one particular broker goes down and unavailable to serve the request, what will happen if we have replication of the same partition in another broker or another server, then that replicated data can serve the requirement. That particular partition, which is basically replicated data what we have stored in another server, that can fulfill the requirement, okay? And that's the importance of the replication, okay? So in Kafka, the replication happens in the partition granularity, okay? So it is not like single message will be replicated. What will happen, from one server, one complete partition is replicated and placed in another server. Okay, so that's what is written here. The replication happens in partition level, not a single message level. Okay, and that is indicating copies of partition maintained in multiple brokers. Okay, so we store one particular partition. For that replications we are going to store in different servers. Okay, that's the concept of replication. Okay, so let's see this particular diagram which will make our concept clear. So suppose I am having a topic and this is having 4 partition. Okay, so what will happen if you observe this? This is partition 0, this is partition 1, here we are having partition 2, and where we are having partition 3. All partitions are available in different servers or brokers, and their replications we are storing in another server. Okay, see, for topic 1 the partition 0 we are storing in another server which is server 2. Okay, for topic 1 the partition 1 we are storing in server 4. Okay, for topic 2 which is basically in server 4, for that the replication or partition we are storing in this particular server 3. Okay, similarly like that for topic 1, for the third partition we are storing the replicated data in the first server. Okay, so that way what will happen, you just consider, suppose our broker 1 goes down for some reason. Okay, so here we are having our partition data. So what will happen if this particular broker goes down, as the replication data is available in this particular broker 2, same partition 0 only available here, so this can fulfill the requirement. Okay, so that way it will be fault tolerant. Okay, right, I hope up to this it is clear. So overall, as you can see, we are having total 4 partition, and suppose the replication factor we can configure. I will be showing you while creating the topic. That time we can say what should be the replication factor. So in this case the replication factor is 2. That means total there will be 8 partition in our Kafka cluster for this topic. Okay, and as you can see there are total 8 partitions. Okay, that's the simple concept. That is, total number of partitions will be nothing but number of partitions we want to configure in our topic multiplied by number of replications. Okay, P multiplied by R. That's the simple formula, right? And this image I have taken from this particular blog. The link I'll be providing in the description box. You can check from there obviously. Okay, so another important thing here you can see, one is leader, one is in sync replica. What is that? Let us try to understand. So what is leader? That is, out of all the replicas for a particular partition, there is a replica that is designated as leader. Okay, so here you can see these pink colors are leaders. What the leader do? The leader is responsible for sending and receiving the data for that partition. Okay, so here you can see for the topic 1, the partition 0 which is available in first broker, that is leader. Okay, so this is leader. This will serve all the read and write request. Okay, and this one will be termed as in sync replica. That is, apart from leader, whatever other partitions will be there in other servers as replicated data, those will be termed as in sync replica. Okay, so the leader is responsible for sending and receiving data for the partition, and all other replicas are called in sync replica. So for the partition 0, this one is in sync replica. For the partition 1, this is basically in sync replica, and this is basically our leader. Okay, for the partition 2, this is leader and this is our in sync replica. For the partition 3, this is leader. This will serve all the requests for read and write, and this is our in sync replica. That's how it is happening. Okay, now what happens when a broker goes down? So this is our leader, and suppose the broker goes down. Okay, suppose it is not available. For the partition 0, it is stored in 2 places. One is broker 1 and broker 2. But in broker 1, this is basically leader which is serving all the read and write requests. And this is basically just for replication. We are replicating the data in this particular partition. Okay. And suppose the broker goes down, then the leader itself is down. So what will happen? Kafka will automatically make this particular partition as leader. Okay. So you just remember this, that when a broker goes down, Kafka automatically select one of the in sync replica and make that one as leader. And after that, that particular in sync replica which is basically converted to leader, that will serve all the read and write request. Okay, as simple as that. So I hope the picture is little bit clear to you. Now let's switch to the lab section. It will be much more clear to us. Okay, so here what we will do, to start our Kafka server, we will start our Zookeeper. Okay, but before that, let me just clear all the server logs and Zookeeper logs to show you the experiment from scratch. Okay. Right. I have cleared everything. So I will start my Zookeeper. Okay. So here my Zookeeper is started, which is running in port 2181 in localhost. Okay. Now I will start my Kafka server. So already in my previous video, I have created 3 different properties file, one for first server, one for second server, one for third server. And the IDs are, for the first one, the broker ID is 0. For the next one, the broker ID is 1. For the next one, the broker ID is 2. The first one is running at port 9092. Next one is running at 9093. And next one is running at 9094. Okay. So I will start the servers. So here you can see this particular server is running at port 9092. This server will start running at port 9093. Here you can see port number 9093. And in another terminal I will go and I will start my last server, which is having the broker ID 2. Okay. So here you can see ID is 2 and the server is running at port 9094. Perfect, right? Even I can check the broker IDs using this Zookeeper cell.bat file. If you are using Linux, you can basically use the sh file. So here you can see the broker IDs which are running in our cluster is 0, 1 and 2. Okay, perfect. Now what I will do, I will create a topic. The only difference this time is, earlier I have used replication factor 1 in my all previous videos. Now this time I am using replication factor 3. Okay, and partition I am using 7. So 7 partition, 3 replication. And what is replication factor? Replication factor is basically nothing but the number of times one single partition is getting replicated. So one partition is replicated 3 times. There are total 7 partitions for our topic. So 7 multiplied by 3, that is 21 partitions we will be getting in our cluster. Okay, I will copy this one and I will paste this. And here you can see our topic is created. Okay, let's go back to our server logs and let's see whether 21 folders are created or not. Okay, so here I will go back to my first server log, and here you will see that partition 0, partition 1, partition 2, partition 3, partition 4, partition 5 and partition 6. 6 partitions are created for this particular topic. Okay, right, in the server 1. Okay, if I go to server 2, I will see the same. Okay, if I go to server 3, I will see the same. Okay, right? So basically total 21 files is created. Now how to understand for which partition, which broker is the leader? Like here we have seen, right, that for different partition, there is a leader broker, and that is basically called leader partition, and all other partitions are called in sync. So how we can understand that which is leader and which is replication, right? Like here you can see partition 0 is available in third server, second server, first server, everywhere. Which one is leader, which one is in sync? So to understand that, you have to execute this particular script. Okay, what you have to do, first you have to run your Kafka Topic.bat file with the complete location where actually this bat file is present. Like in my case, it is stored in F drive. Okay, and I am starting that particular script with all the 3 servers wherever our Kafka server is running, and we are using describe command to describe this particular topic what we created. Okay, so here I will just copy this one and I will paste that and I will hit an enter, and then here we will see what are the partition and who is the leader. Okay, very important point, try to understand. For partition 0, the leader is broker 1. So here in this case, leader 1 is basically broker ID 1. Broker ID 1 is nothing but our server 2, because for our case the broker ID is starting from 0, right? So leader 1 is basically indicating second broker or second server is basically having the leader for our partition 0. Okay, so for partition 0, the leader is basically, if I go to second server and if I go to 0th partition, this is basically the leader. Okay, and other partitions for the partition 0, whatever stored in other server, those are called in sync replicas. Okay, simple. And here you can see replicas. Replicas are indicating in which servers or brokers our replications is stored. So replication is stored in 0, 1, 2 everywhere. Okay, ISR is nothing but indicating in sync replica. Okay, so for our case, all 3 servers are currently up and running. So here we will be getting the same list 1, 0 and 2. For all the servers, the informations are synchronized. Okay. Now we will see what change happens when one server goes down and all this. But as of now, I hope you are getting, like here, if you are asked that who is the leader for partition 1. So for partition 1, the leader is basically our first server. Okay. Or broker ID 0. And replications are available in all the 3 servers. So all are in sync, right? So I hope you are getting it. Now what I will do, I will start my producer. Okay. So here I have started my producer, and here what I will do, I will open command prompt and I will start my consumer. Okay, perfect. So I will just make this a little smaller and side by side. So here I can put messages, hi. Here you can see in the consumer side it is coming. This is the second message. Here it came. January, February, March, April, May, June, July, August, September. Like that, I am passing some dummy messages, and we can see the producers are able to produce the message and consumers are able to consume. Here also, when we are having multiple replications from the producer and consumer side, no change in the operation we can see. Just producers are producing messages and consumers are consuming the messages. Okay, but if we go back to the server logs, we will see the impact. Okay, for having multiple replicas, I will show you. So let's just consider our server 0 or our first server. Okay, so partition 1, which is stored in our server 0 or first server, that is basically acting like leader. Okay, so let's see the partition 1. So I will go to Kafka logs, and in my first server, which is server 0, I'll be going to partition 1. Okay, so here if I just check the data or the messages whatever stored in this partition, they are basically February, October, these two. Okay, now what will happen, because we have kept replication factor as 3, in other servers also in the same partition, that is partition 1, the same message will be replicated. Let me show you that. Okay, so what I will do, I will open this in Notepad++. So this particular one is from our first server, right? So let's go to other server logs for the same partition. So here I will go back to this server and partition 1, and I will open it Notepad++. Here also, this particular log which is present in our second server or broker ID 1, okay, there also you will see under that partition February and October, same message is stored, whatever is stored in first log. Okay, even if I go to our next server which is having broker ID 2 or server log 3, okay, so in this particular log also we will able to see the same thing. Okay, so here what is happening, that all the replications are basically storing the same data, but for this particular partition, which is partition 1, actual leader or our main partition is stored in our server 0 or the first server. Okay, like that's the simple concept. And like that you can check any other partitions. Basically replication data will be same in different servers. Only thing is one particular server is leader and other are in sync replicas. That's the only difference. Okay, now what I will do, I will basically stop my consumer. Okay, and now what I will do, I will stop my one server. So suppose I am basically stopping my first server. Okay, so first server is running, I will stop my first server. Terminate. Why? Okay, so I have terminated my first server. See, in producer side it is perfectly running. If I start my consumer, in our previous video we have seen when we basically started our multiple server Kafka cluster, but we have not enabled replication, then if one server is down, then in that server whatever data is present, that we were not able to get when we are starting a new consumer, right? But this time replicated data is present in different servers. So if I just start running this particular consumer, here we will see the same thing. Like see, May 1, okay, July, high school, January, March, August, this is second message, April, June. All these messages, whatever we publish from producers, all are coming. It is like one server is down, but still the complete information we are able to get. Just one warning message we are getting that first broker which is running in localhost 9092, that is not accessible. That's fine, but at least we are able to fetch all the information, right? And even I can publish some more messages, like here. If I just put a new message, publish data, here we will see that publish data is coming. Another like that, another one. If you are passing, here we'll be getting another one. So our producers and consumers is not at all impacting. Okay, that's the beauty of replication, right? So I will just close this. And this time, let's see what impact happening in the leader broker. Okay, so I have told you while having discussion on theory that when a broker goes down, Kafka automatically select one of its in-sync replicas and make them leader, right? So here our broker 0 went down. So for the partition 1, whatever stored in our broker 0, that was the leader. Okay, so now this will not be leader. Somewhere else where partition 1 replica is present as in-sync replica, that will become the leader. Similarly for partition 4, the broker 0 is the leader, so that will also change. Okay, so let's see if I just execute this one. Here this time, let's see what we are getting. See, for partition 1, now the leader became the broker number 2, that is our third server became the leader. Okay, Kafka automatically changed the leader to one in-sync replica. Basically earlier in broker 2, in-sync replica of partition was stored, but now that in-sync replica became the leader. Similarly, following same way for the partition 4, the broker 0 was the leader, but now the leader became broker 1, that is our second server. Okay, right? So I hope you are getting that. And one more thing you can observe here, currently ISR, earlier ISR was 102 because all the servers were up and running. So in-sync replicas was present in all the servers. Okay, but this time ISR changed to 1 and 2 only. That is our second and third server only having in-sync replica. Our broker 0 or server 0 is basically down. So in that particular server, whatever partition is present, that is no longer in sync. That is not synchronized. Okay, so ISR also changed. Okay, now none of the leader is basically leader 0, and in ISR also you will not see broker 0 because that is down. So there whatever data is present, that is not in sync. That's what our Kafka is indicating with this particular setup. Okay, I hope it is clear to you. Now let's do one more thing. Let's make another server down. Okay, so I will make my second broker also down, which is running in localhost 9093. Okay, and I will make an enter. And now this time, if I just start running my consumer here, let's see what message we get. So here we are getting two warnings that localhost 9093, that is our second server, and our first server, which is running at localhost 9092, both are basically down. Okay, right? So that's why this kind of warnings are coming, but that's fine. We no need to worry. Still, we are able to get the complete message. Okay, because at least one server is running and that is having all the information, right? Now let's see how the leader got changed. So this time our second server, which is basically having ID 1, that is also down, right? So now this time if I execute this particular same code to understand who are leader, who are in-sync replicas, we should not see any leader who is basically server 1. We should only see all leaders are basically our last server, which is server 2. That is our third server. Okay, if I just run it, here you will see that only leader 2, for all the partitions, the leader is basically our only one single server which is running, and in sync replica is only 2. Earlier it was 1 and 2, that is second server and third server, but this time only the last server is in sync replica because all other are down, right? But still I can publish the messages and do all this activity. Something I can write and hit enter, and here also you will see that same message is coming here. Okay, PJHV like that. And here also it is showing the message that to this server it is not able to connect. That's fine, but for our case it is working, right? So like for example, I will be publishing messages IIPPLLSS something. Okay, here you will see IIPPLLSS. That is 2 servers are down out of 3, but still we are able to get complete message as well as our consumer is able to consume the new messages. Okay, right? Now let's make our all the servers whatever was down, just let's make them up and running. So here I will start my first server, and here I will start my second server also again. Okay, so here they are going to take some time to start, and now both are started. Now the producer and consumer is working like just as it is 1 2 3 4 5 6 7 8 9 like that. Some message if I am publishing, here you will see that message is coming. That is from producer and consumer side, there is no impact. Only thing is now all the servers are up and running. So what would happen that currently for all the partitions the leader is present in our server 3 which is having ID 2. Okay, but this should not happen. Eventually that load should be distributed among all the running servers, which is now perfectly running like server 0 and server 1, and the in-sync replica also from 2 it should change to 0 1 and 2 because all the servers are now running. Like if I just run this particular describe topic once more, here you will see that in-sync replica became 210 because all the servers are now running. So eventually all will become in sync, and currently you can see there is server 2 is the only leader, that is our third server, or broker ID 2 is the only leader. But this should not happen. The workload should be uniformly distributed and leaders should be in different servers. It is not like all the leaders will be present in same server. So after some time you will see that some leader partitions are moved to some other servers. If I just execute now, so it is going to take some time. Let's wait for a couple of seconds and we will see that other servers will become the leader for different partitions. The load will be distributed from server 2 or broker ID 2 to different places. Okay, and that's the concept about replication in multiple servers Kafka cluster. Okay, and once you understand all the theory importance, like what is importance of partitioning, what is importance of replication, how the logs are working in the back end, now you've got the complete picture, and now you can start the programming in Python in full fledged. Okay, but if you directly jump into Python programming without understanding the theory behind that, what would happen? That you will not get the complete feeling, or you will find it very difficult to debug your problem. Okay, so that's why I thought to discuss the theory first and then switch to the programming section. Okay, so here you can see that currently still the leader is 2. Let's wait a little bit. So now here you can see the leaders are now not only broker 2 or server 3, now the leaders are distributed among different servers. Okay, so that's how Kafka is doing load balancing kind of thing in the backend, right? So I hope you got it. This is all for this video. Thank you for watching.